Good morning, everyone. Because my lecture was not recorded last night, I'm redoing at my side at home. Chi-square testing. We've done this using Microsoft Excel programs yesterday. Today what we will do is the same testing in Python language. What we need to do first, I assume that you have a Python installed on your computer, excuse me. Let's say Python 3.4. Then you need to download it from here, scipy.org. From here, you can click to find the proper downloadable the packages, the Python packages. This is that one. This is the first page of that scipy.org. If you scroll down, then there's some released packages available. So I'm going to click on the first one. And there are two packages available, numpy and scipy. What I want you to do is to download both of these. Okay, if you click numpy, and then click numpy again, and I want you to click 1.9.1 again, and therefore you can see some of the files, but the one that I ask you to do is if you move your mouse on the super pack list, then you can see the annotation, the top one here, that is for Python 3.4. So if you click this, therefore you can download it. Don't try to click anything, but wait so that you can save the file. But I saved the file already. I want you to do for both numpy and scipy. Scipy for science, numpy for the Python dealing with the numbers. When you download it, after that you can bring that to your Python directory. In my case, underneath C drive, I have multiple Python versions. So I'm going to click Python 3.4 and then bring that in the lib directory. And as you can see, I have those two files, numpy 1.9.1 and so on and so forth, and the other one scipy. So these two files are executable. So if you do double click, then it is automatically installed. What they were installed is under the directory of sci packages folder. If you open sci packages by double click, then you can find the sub folders, SCIPy and NumPy. If you install, for example, you need to install both of these. Click those. So for example, if I click SciPy and also NumPy, there's a setup button. So you need to, set up program. This is Python file. So you have to double click this setup. Therefore, SciPy package is properly installed. The same way that you need to do for NumPy. Okay. Once you have done that, when you come back and launch the Python program like this, what I typed here, after the prompt, I typed C colon backslash Python 34 backslash Python and enter. Then I can get Python interactive mode prompt. There we need to do some exercise. Okay. So it takes a little time. Still. These are some programs that I tested. But I will do this with you in a minute. Oh, it was not. I'm sorry. It was not entered. Okay, I have prompt. To verify the completion of your NumPy and SciPy installation, you try to import NumPy and also Science Python. Both of are properly installed. If it is not properly installed, then you might have some error messages. What I want to do to make it simple, I want to use alias name. So I can call it NP for NumPy. And also for SciPy, this in the Science Python, I want to use a statistics module, so stats, and I call it chi, for example. It works. And what we had previously, we had this data, like the one we had here and also there. So this observed frequency data is only what we can collect. All others can be generated. So observed data is this, the same data that I am using. So if you hit enter, this, I'm going to put it in an array. To use that, then I need to assign that to a variable. Let's call it observed. Then that is observed. And After that, what I want to do is I'm going to generate expected frequency and put it in another variable called expected, like this. Expected equal chi. Chi is nothing but SCI pi dot stats dot contingency dot expected underscore frequency. This method, this function takes the observed arrays and then generate expected frequencies. And I'm going to put that on the new variable expected. All right? If I want to see what the expected frequency is, then you can type print expected. Those are the numbers that we generated. I want you to recall the Excel experiments, right? This is the given observed data set frequencies, and this is generated. What actually is, these are what we expected. Numbers are generated based upon the probabilities of those observed data. So this is not just arbitrary numbers. This is expected, reasonable expected. After this, then we need to run chiSQ program. All right? So that is called here. There's a chiSQ. Chi.chi.chi2. Actually, if I spell it, then scipy.stats dot chi2. This chi2 module takes two parameters. Observed, that is this, right? The array. And expected, that is another array. Actually, if you are not familiar with the Python, the actual number that you can retype here, I'm going to scratch that. What you do is this. Chi2 takes the list of those four numbers, observed number, and the expected numbers also taken by these modules with some of the variable, f frequency underscore expect. Okay, so that equals that list. This is the language. This is the way that function was defined. So we just follow the grammar. Okay, if you hit enter, then you can see the two numbers. The first number is chi number, chi2 number. The other number is p-value. Remember the p-value that we calculated from Excel program. This value is similar to that, right? Another tip that you could do is I can assign this chi value and p value to a separate variable. So first value can be assigned to the variable c, and second value assigned to the p value. And hit enter, and then you can print c, then that is chi value, print p, then that is p value. So based upon p value, then you can see, remember that chi2 testing determines whether we want to keep null hypothesis or reject. But in this case, we need to reject. All right? I hope you understand how you could use Python programs for chi-square testing. Have a good day.